In this topic, we will be solving absolute value equations. To begin, let's actually start with the definition of what an absolute value is. The absolute value of a quantity q, written as the absolute value of q, is defined as the distance between q and 0 on the real number line. Now, most of you have already worked with absolute values before, that is, absolute values of numbers, but let's quickly review. If we have the absolute value of 4 in words, this means what is the distance between 4 and 0 on the number line. Okay, so let's take a visual picture. Looking at the number line, the distance between 4 and 0 is how many units? 1, 2, 3, 4 units. Therefore, we say that the absolute value of 4 is 4. Similarly, if we take the absolute value of negative 4, it also represents the distance from 0 on the number line. And again, if we refer over to the number line and count the number of units between 0 and negative 4, the number of spaces, the number of units between 0 and negative 4 is also 4. It's 4 units apart between negative 4 and 0. And thus, the absolute value of negative 4 is also 4. Absolute values represent a distance, and distance is the same whether you go forward or backwards. So in both cases, the absolute value of 4 and the absolute value of negative 4 is positive 4. Now, our job will not be to just simplify absolute value expressions, but rather to solve equations that involve absolute values. So, like for example, we would solve the following equations. The absolute value of x plus 3 equals 8. Or another example, the absolute value of x minus 7 equals negative 2. These are examples of absolute value equations, equations involving an unknown and which contain absolute value signs. Now, when we solve these equations, there's two things we want to remember. First of all, when we solve these equations, we'll be getting two answers or two cases. And the second thing you want to remember is that you always want to isolate your absolute value first. So let's get started on some examples. Before we begin with actual examples, let's take a closer look again at an absolute value equation. Let's take the absolute value equation, absolute value of x equals 4. And I want to solve for x. I want to find the value of x that makes this true. Well, let's think about something earlier that we talked about. We talked about the fact that the absolute value of 4 was 4. And also, do you remember the absolute value of negative 4 was 4? Because both 4 and negative 4 are 4 units away from 0 on the number line. This means that there are actually two answers that x could be to make this equation true. X could be the number 4, or x could be the number negative 4. Hence, when we solve absolute value equations, we have to be aware of this fact and account for both cases in both solutions, the positive value of x and the negative value of x. All right, so let's actually now start those examples. Example number 1. Solve the absolute value equation, the absolute value of the quantity 4x plus 3 equals 19. Let's take a closer look at this problem. We have an absolute value of something, in this case 4x plus 3, and it's equal to the number 19. Now let's refer back to our previous discussions. There are actually two numbers that we can put into this absolute value sign that will give us an absolute value equivalent to 19. That first number is 19, right? Because if you take the absolute value of 19, you get 19. But then the second number is negative 19. Because when you take the absolute value of negative 19, you also get positive 19. That means that the expression 4x plus 3 is equivalent to two different answers. 4x plus 3 is equivalent to 19, or it could also be equivalent to negative 19. Because both of those numbers, when placed in the absolute value, give us positive 19. This creates for us two cases that we were talking about earlier. Let me write them down for you. In the first case, 4x plus 3 equals positive 19. Or, and then the second case, 4x plus 3 equals negative 19. At this point, all we have to do to finish the problem is solve each of these linear equations, and we'll get two answers. But I want to point out something. Notice, our absolute value equation here has an absolute value. However, to solve it, what we did was we dissected it by taking a look at the expression within, 4x plus 3, and realizing that it could actually be one of two numbers. So we wrote two linear equations from one absolute value equation. All right, so let's continue to solve each side. Let's solve the left side first, and I'll put the steps down quickly. Using reverse operations, we subtract 3 from both sides, giving us 4x plus 16. And dividing both sides by 4 gives us x equals 4 for the first equation. Let's go and proceed to solve the second one now. Using reverse operations, we subtract 3 from both sides. On the right side, this gives us negative 19 minus 3, which is negative 22. And then we're going to divide both sides by 4. This gives us x equals negative 11 halves. Negative 22 fourths reduces to negative 11 halves. There are two answers to this equation. X equals 4 and x equals negative 11 halves. Now, I want to show you that both of these answers will work to make this equation true. So this will be the only time I actually physically check this problem for you, but I think it's important that you observe this and you understand that both answers work. So let's check. Let's start by checking x equals 4, and let's see if this is true. When I put the 4 back in, it gives us a solution to the equation. So here we go. We're going to put 4 in place of x. So we have the absolute value of 4 times 4 plus 3 equals 19. Simplify the stuff inside. That gives us 16 plus 3, and is that equal to 19? Well, 16 plus 3 is just 19, so the absolute value of 19 definitely is equal to 19. That answer checks perfectly. Let's quickly check the other answer, x equals negative 11 halves. So we're going to take negative 11 halves and put it back up here into our original equation in place of x. So we are determining 4 times negative 11 halves plus 3. Does that quantity and absolute value equal 19? Well, let's simplify the left side. The 4 and the 2 cancel. Gives us 2 times negative 11, or negative 22 plus 3. And negative 22 plus 3 is actually negative 19. The absolute value of negative 19 is definitely 19, and so that answer checks as well. The two solutions to our absolute value equation are x equals 4, x equals negative 11 halves, and your book, just to let you know, might write these two answers in set notation, 4, negative 11 halves. Either answer is acceptable in my book. Okay. Let's move on to the next example. Here's example 2. Solve the absolute value equation. Absolute value of the quantity 2x minus 7, quantity closed, plus 4 equals 15. Now, to start this problem, we want to take this absolute value equation and make it look like the one in the previous example, meaning that we want to isolate the absolute value on the left side and put all the constant terms on the right. To do this, we're going to use reverse operations, and we're going to get rid of the 4, moving it over next to the 15 by subtracting it from both sides. That is to say, we obtain the equation absolute value of 2x minus 7 equals 11. Now we're ready to proceed as we did in example 1. Remembering that 2x minus 7, the expression within this absolute value, could be one of two things. Remember? inside the absolute value, we're setting it equal to 11. This is kind of funny, huh? Looks like a big 11 here. But anyways, these are the absolute value signs, equal to 11. And there are two numbers that we can put in those absolute value signs, 11 or negative 11. Oh, look at all those straight lines. If you're not confused, I'm confused. But seriously, take 11, put it in the absolute value, and you get 11. Take negative 11, put it in the absolute value, you also get 11 because both of those numbers are 11 units away from 0 on the number line. So we will create two equations based on the expression 2x minus 7. 2x minus 7 is equal to 11, or 2x minus 7 is equal to negative 11. Now let's solve each linear equation. Using reverse operations on the first one, we add 7 to both sides, giving us 2x equals 18. Dividing both sides by 2 gives us the final answer of x equals 9. Let's solve the second equation now to find our second answer. Using reverse operations, again, we add 7 to both sides, giving us 2x equals negative 4. Dividing both sides by 2 gives us x equals negative 2. That means there are two answers to our problem. X in our problem could be 9 or negative 2, also written in the set notation as negative 2 comma 9. I will leave it to you to check that both of these answers, when placed into this equation, give you the correct solution. All right, we'll move on to the next example. This brings us to the last example in our topic, example 3. Solve the absolute value equation. Absolute value of the quantity x plus 5, quantity closed, plus 8 equals 0. Now, as with example 2, our first step is to isolate the absolute value sign on the left side so that we only have an absolute value, all the constants are on the right. To do this, we're going to use reverse operations. By subtracting 8 from each side, this leaves us with the absolute value equation. Absolute value of x plus 5 equals negative 8. Now we're ready to proceed and analyze a little farther because our absolute value is isolated. Remember, we took a look at the absolute value and then we tried to figure out what things we can put inside to equal this number. So in this case, we're looking for two things that we can put inside that's equal to negative 8 when we take its absolute value. Now wait a second here. If we put 8 in the absolute value, we don't get negative 8, do we? Because the absolute value of 8 is always positive 8, not negative 8. So that guy doesn't work. And if we put negative 8 in here, that also doesn't work, does it? Because when we take the absolute value of negative 8, that too is equal to positive 8 because remember, absolute value represents distance from 0 and that distance is always a positive. That means negative 8 also doesn't work. In fact, think about it. There is nothing that you can put in here so that when you take the absolute value you get a negative 8. Why is that? Because absolute value, remember, always has to be a positive number. So this is kind of a trick equation. There is no solution to this equation. There is no number that we can put into the absolute value so that when we add 5 to it and then add 8, it will give us 0. It's impossible. There's nothing you can put in there. So this is a special case of the absolute value equations. The solution to this is no solution. There is no number that will work in this equation. Sometimes you see it designated with the empty set, the null set. That also means no solution. All right, that ends our topic on absolute value equations.